Okay, we were in the process of synthetically dividing with -1/4, and it worked. And I think, so, remember my drawing is terrible, but I do remember when I made the drawing that this one was real close here, and this one was much closer to the 1. So remember, these are all our possible roots, and we're supposed to be picking from that to try to figure out what our roots are. So obviously, it's got to be less, it's a fraction, it's got to be less than 1, but it's close to the 1. So that means it's probably not a third or a half or a fourth or a sixth, because all of those would be closer to 0. So it could be 2/3 or it could be 5/6. Want to try 5/6?
Yeah, 5/6.
Okay, so we're going to use these numbers that we got as a remainder because it was quartic. When we got down this far, now it's cubic, and we want to get to quadratic. So we would like for to use those so that we're 1 degree down. So, okay, so we said 5/6. So I'm going to put 5/6 out here. Do we think, oh, it's positive, right? It's on the positive side. 5/6. Remember, you divide by the 6, then multiply by the 5. So that'd be 18. Okay, I'm going to go out on a limb here and say right there that it's probably not 5/6.
Yep.
Because right there, 26 is not evenly divisible by 6. Now, that doesn't mean that you can't have fractions when you're synthetically dividing. You absolutely can. But I wouldn't think that they would do that on this particular thing. So let's assume it's not 5/6, and if we can't find it, we'll come back to 5/6. That gives us our only other option being 2/3. So let's try 2/3. Again, I'm using 12, 16, 40, 44, -40, so I'm going to rewrite them. And I'm going to go 2/3.
This one's a 7.
That doesn't work either.
Yeah, it does.
What did I do wrong?
Keep going. 60 divided by 3 is 20.
Oh, and it's 40. Hello. I can't divide. That's my problem.
And
Okay. Okay, so now we get down to a quadratic, which we can then factor. Now, that quadratic, before you start jumping on the bottoms up bandwagon, it has a GCF of 12. So I'm going to write it down. 12x squared plus 24x plus 60, but to factor out the 12 first, because now it's just a simple trinomial.
So whatever 2 you find first, you can always use the third one? Is that how it works?
You mean to
Synthetically divide?
after you synthetically divide, you mean the second one you can always use to
Yeah.
factor?
No.
Not necessarily. In this case, the reason you can is because we started out quartic. So we found 1 and then 2 and we got down to quadratic. If we started out quintic, we would have to find 3 first to get all the way down to quadratic.
But as soon as you hit quadratic, you can use it no matter what numbers?
Yes, you can, and then you get to a quadratic that you can factor, except this one doesn't factor. But, okay, so we factored the 12 out, and now we have x squared plus 2x plus 5. It doesn't factor, but the quadratic formula will always work, and so will completing this square. So either one of those two that you're comfortable using is what we're going to use at this point. Remember what we discovered. Since this was yesterday, it's hard to remember. We've found these two. So we know our next two have to be imaginary. And if they're going to be imaginary, it means you have to take a square root somewhere in this process, which means that you were doomed from the beginning to either use the quadratic formula or either one. But so I'm going to use quadratic formula because I think that's probably the one that you guys are most familiar with, and would probably be the one that most of you would choose to use. Oh, I didn't write in the blank. The resulting polynomial was quadratic. Okay, so okay, so disregard the 12. We factored that out, so it's not a concern. It's just this that we're using and plugging into the quadratic formula. Okay, so I got to this, -2 plus or minus 4i, because inside of my radical I have -16. 16 is a perfect square, so that gives me 4i. Now, 2 goes into all of those pieces, and all of those pieces are outside of the radical, so you can simplify. It ends up -1 plus or minus 2i. So remember, that's your other 2 roots. So all together, if we list our roots, don't forget to list the ones that you found in the beginning. So f of x has roots x equals -1/4, 2/3, and then -1 plus 2i, and -1 minus 2i. So that's all 4. Okay, so based on everything we've done, now it says at the top of the page, let's provide a plan on how to find all of the roots of the polynomial function. Okay, so what do you think we should do first? What's the first step?
Look at the function.
Look at the function, and when we look at it, what are we looking for?
Determine whether
Constants are.
The constant term. That's exactly what you're looking for. If it has a constant term, then you know there are no zeros that are 0. Okay, after we determine if any zeros are 0, then what would our next step be, you think?
Look at the lead coefficient.
Do what?
The lead coefficient.
The lead coefficient. What's that going to tell us?
If it's positive or negative.
Does that help us? To find zeros.
No,
Look
no.
at the positive function and look for sign changes.
Okay, so Descartes rule, positive function first. And then after that, I would probably say we're going to do Descartes' rule again with f of -x. Because that's going to help us just determine positive and negative roots.
And you gotta find all your possible roots.
Then you got to find your PRR list, right?
the worst part.
Yeah, I agree. And then, once we've done that, then your next step is just to start synthetically dividing. And then solve the quadratic. However you have to do that, factoring or a quadratic formula or the square. Okay, so let's do it. We're going to first look at so on number 1, we're going to first look at our function and find for a constant term. It has one, which means if you were going to make a chart, you have no 0 roots. So I can go ahead and put a 0. I have none of those. I'm going to put it twice because I'm going to assume we're going to have at least 2 options. Okay, so now I'm going to count sign changes. None, which means I have no positive roots. That's a little crazy. Now we're going to do Descartes' rule with negative x. Fast. Okay, so let's see. on negatives, so 3 or 1, which means I might potentially have 2 imaginary. Okay, so now this does help us when we make our PRR list. I don't have to bother putting any positive signs, because I don't have any positive roots. So I'm only looking for negative roots here. Okay, so my PRR list, remember, that is factors of the constant over factors of the league. So 1, 2, 3, 6. That is not a bad list at all. Okay, so I'm looking up at my function. What do you guys think? What should we start with?
Negative third.
I'd probably say -3, but and honestly, I really don't know what the answer is. Okay, but we'll just, what do we, actually, I have an idea. Let's all do something different, and then we can tell each other, and then that way we don't spend 5 hours trying to figure it out. So I'm gonna go with -3.
I'll do negative
I'll do
1.
1
I'm gonna do
Negative
negative 2.
1 third.
Why go negative 6?
I got negative 2.
Okay, anybody got -2/3? Okay, I think that's all of them.
They get 2/3 this one.
It is? Okay, that's it then, because there's only one, there's
Yeah, negative 2.
-3.
Negative 6 is
Yeah,
not
negative
one.
1/3.
Yeah.
Okay, so but -2/3 is. Okay, so Jacob, okay, so let's all do -2/3 because we know that's it. We want to show it on our page. That made it a whole lot faster.
Three, 6, 9.
Okay, so this is a quadratic. 3x squared plus 6x plus 9.
Factor out of 3.
Factor out of 3. So x squared plus 2x plus 3 doesn't factor because their signs are both positive, so there are no factors of 3 that would add to give you 2. So, quadratic formula.
Do we have to do the quadratic?
Or complete the square. Okay, so I got this far. Plugged in the quadratic formula, and I was simplifying. I got 4 minus 12, this gives me -8. -8 breaks down, it's kind of one that I've got memorized. 8 breaks down into 2 square roots of 2. So it's minus 2i square roots of 2, or plus or minus. So I did. I don't know why I put minus. I put plus or minus. So this is where I am right now. Because I broke this down into 2 square roots of 2 and it was negative, so it had to be 2i's. Everybody okay? Understand what I did? Okay, so now right here, outside pieces can simplify with outside pieces, not inside pieces. But all of the outside pieces do even evenly divide by 2, so you can simplify those, but nothing will happen to the inside piece because he's inside, so it can't be simplified. But your final answer ends up being -1 plus or minus. It would be 1i, but you don't have to write the 1. So you can just write I square root of 2. So I'm going to list my roots. So x equals -2/3. X equals -1 plus I square root 2. And x equals -1 minus I square root 2. And that's all 3. Okay, so you guys do number 2. Follow the steps. You can do what we did and everybody pick a different PRR once you get to that step. It helps, I think, go faster. It's longer.
When it's a negative lead coefficient, do we need to make the factors of it negative?
You use both the positive and negative values anyway, so.
Oh, that's right.
we still need another one of them. Did anybody, I'm just curious, cause it could touch and turn there, anybody try to use 3/2 twice? Cause that can happen. When you find one, sometimes they just try to use it again. Just in case.
So 3/2 is one?
Yeah, Jacob found 3/2. I'm just gonna go ahead,
I don't think 1/2 is one. It was positive.
I'm gonna skip to, anybody make the chart?
Yes.
Negative 1/3 is one. Negative 1/3?
Good, so that, okay, so that means we have
There's-
enough.
There's one positive that it, or it, a guaranteed one positive. That
Okay,
And
there's
then three
either
or one.
3 negatives or 1 negative,
okay,
no zeros.
so that would be 1.
Yeah, negative 1/3 is one. I tried to do positive.
Okay, so negative 1/3 is 1, and Jacob got, 3/2 is 1, so that could get us down to quadratic. So that's all we need.
Yeah, it can't be get 3/2 twice because it's on the.
Oh, cause it's, yeah, you're right, cause it's positive. Okay, so I got negative 6x squared minus 6x minus 6, factor out of 6. So factor out of negative 6. X squared plus x plus 1. So we know, because this was negative and this one's positive, that we're looking for this one.
Forgot to use the bottom.
So this goes in the quadratic formula.